Hello and welcome to the webinar User-Defined Attributes in PTV Vissim. User-defined attributes allow you to create and use your own data or formula-based attributes in Vissim. Within the next 40 minutes, you will learn about how to create user-defined attributes and what are they good for. Then I will show you 3 application examples like extended labeling, GAH statistic, and node level of service calculation. Before I start, there is some technical information about the webinar. Attendees are not able to use their microphone, but you are free to post comments and questions via the questions window. I am Peter Sukenik, Product Manager at PTV Vissim at PTV headquarters in Karlsruhe, Germany. My colleague Sven Baller, who is also Product Manager for PTV Vissim, will reply during the webinar. After the webinar, we both will be available for some time to answer your questions via the questions window. Let's now go ahead. What are the user-defined attributes good for? Let's answer this question. You can show more dynamic information in your model and extend your labels. For example, label objects with interesting information like remaining green time. You can store, show, and output your own data. You can show additional data or information, for example, traffic counts, or support data calibration like GAH statistic. You can continue to process result attributes like calculation of level of service. Or just calculate whatever you want based on your model data. For that, you can define your own formulas. Next part of the webinar, application examples. Example number 1, extended labeling. The idea is I want to demonstrate differences in driving behavior when changing W74AX parameter, which is average standstill distance of vehicles. Solution, I will create a network with 5 links with the same input but different W74AX parameters, and will let Vissim show number of vehicles passing during one signal control cycle. I will create 2 user-defined attributes, label for links to show W74AX parameter value, and label for data collection points to show the number of passed vehicles. Let's go to Vissim. This is my simple network. Here in this area, the signal heads and data collection points are placed. Now, how to create user-defined attributes? There are more ways. The first one, go to base data and click on user-defined attributes. This opens the list for user-defined attributes. Then you can use the plus button, which opens the dialog for user-defined attributes. Or you can use right-click on your mouse and click on Add. The second way, you can move your cursor to the area of Network Objects window and then use right-click on your mouse and click on Create User-Defined Attribute. This opens the dialog for User-Defined Attribute, and as you can see here, the object type is predefined already. Next way how to create user-defined attribute is to use a list. I will switch to linked list, and here I can use the right-click on my mouse and then click Create User-Defined Attribute to open this dialog, or I can click on Create User-Defined Attribute. Now I will define the first user-defined attribute. As an object type, I have here links, that's correct. Then I need to define the short name, long name. I can write some comments. I need to choose a data type from these possibilities here. And then I need to choose data source type, which can be data or formula. If you switch to formula, it opens the formula field here. Here you can also switch on to create sub-attributes for simulation run or for time interval. On the right side on the dialog you see 4 buttons. The first one here you can use to insert any attribute for the object type, in my case for links. The second button here allows you to insert any operator. For example, plus can be used as a mathematical plus or to concatenate two strings. The next button here, expressions, allows you to insert a function in the formula field. The last button here, 4, named insert table lookup, allows you to access attributes of other object. Now I will fill these fields here, the short name. I will write my label. Long label, I will see it in the list. I can write some comments, and as a data type, I will switch to the text because I want to use this attribute as a label. Here I want to insert some text. For that I will use quotation marks, and here I will write Wiedemann AX, Wiedemann 74AX is equal to, then I will use the operator, the plus, and I will insert via this button here the real value of W74AX parameter. For that I need to go to link behavior type, then to default driving behavior. I will scroll down and I will pick up W74AX parameter. OK. Now when I click on OK, I will get an error message, and that's because I choose the data type text, and this here is a number, so I need to convert this to string. For that I will use the function, so I will click here on expression button, and I will use the function number in string, which converts this number into string. OK. Now when I go to the list of user-defined attributes, I see that I created the first one. Now I can switch on the label visibility for links, and as a label attribute I will choose my label. You can see here that there is a black dot, not the green dot, which means this is a user-defined attribute. Okay, and now you see the combination of my text and the value of Wiedemann 74AX parameter. Now I will create the second user-defined attribute. I will click on plus here, and as object type I will choose data collection measurements this time. I will switch to formula again, and as a data type I will use text again because I will use it as a label again. So here I write my label again, and it will be data collection label to distinguish the labels. And here I want to insert a text, so I use the quotation marks again, and I will write past vehicles. Then I will use the operator plus, and then I will insert an attribute, and it will be a number of vehicles for current simulation run and current time interval. I need to convert this into string again, so I will call the function number in string. Then I will insert the operator plus again because I want to add a text, and here I will write average number of vehicles. Here I will insert the plus operator, and I will insert an attribute, again number of vehicles, but this time I want to get average through all time intervals. Okay, what I need to do to convert this number into string using this function. Okay. Now I can go to data collection points here in network objects, and I can switch the label visibility on. And as a label attribute, I will go to data collection measurements, and I will choose my DC label. Now I can run the simulation. I am not collecting the data during the first time interval, so we have to wait until the second time interval. Now you see the number of passed vehicles for each link, and after next time interval, which will be in a couple of seconds, now we will see the first average value for each link. Now I will switch to quick mode to get the results quickly. That's okay. I will click on stop. And as a result, here you see the average numbers of passed vehicles. You see that these numbers differ because each link has different VDMAN74 AX parameter. That means that the value of this parameter influences the capacity. And I didn't mention that to get the result, the appropriate evaluation must be switched on. In this case is data collection. That was the first example. I'm back in the presentation. Example number 2, GEH statistic. The GEH statistic is a formula used in traffic engineering, traffic forecasting, and traffic modeling to compare two sets of traffic volume. Good message is that you don't have to rewrite this formula into Vissim because it is predefined, as I will show you. As you can see, there are two variables, modeled traffic volume and counted traffic volume. For counted traffic volume, I will create user-defined attribute. Modeled traffic volume I will get directly from Vissim. Common threshold values are 5 and 10. Values below 5 mean that the differences are acceptable. Links with values between 5 and 10 need an investigation, and if the value is higher than 10, the difference is too high. I will use 3 user-defined attributes for links with different data types. Counted data, where I store counted data. GEH, where I calculate GEH value, and GEH check, which tells me if the GEH value is below the threshold value. Let's go to Vissim. Now this is my simple network with one node, and as I mentioned, I will create user-defined attributes for links. So I will go with my cursor to the network object window. I will use the right click and create user-defined attribute. At first, I will create attribute counted data. And in this attribute, I want to store the real counted data from survey. Data type will be integer and data source type will be data. Here I can switch on that this attribute has a minimum value, and that's 0. Okay. Now here I have opened link list, and in this link list I can add my new attribute counted data to the list. Here in the list, these connectors here For these connectors here, I need to insert the real counted values. I copied these values from my Excel sheet. I insert here directly, and these numbers represent the data from survey. Now I will create the second user-defined attribute, again for link, and this time it will be GEH. I can name it GEH value, and I will switch to the data source type formula. And now I will go to function window, and I want to use this function if, which is a conditional branch, outputs W if B is true, outputs F if B is false. Here I will insert attribute. At first I will insert counted data, and I will ask if the counted data is higher than 0, because I want to calculate the GEH value only for that links which have counted data with some value, with some real value. Now here I will insert the second function if. No, sorry. Here I wanted to calculate GEH. It's directly here. What I wanted to show you, I will use for the next attribute. Here I just have to put this GEH function and insert an attribute. I need to get the number of vehicles, so I will go to link evaluation segment, and here I will choose the volume, and I want to get the average through all simulation runs and all time intervals. Okay, and the second set will be the counted data. Okay, the data type, floating point number, that's okay. I'll click OK. And now in my linked list, I will add this GEH value attribute to the list. Now I will create the last attribute, which will be GEH check. It will be formula again, and here I need to use the if function. And at first I will ask if counted data is higher than 0. If yes, then I will ask if the GEH value, so I will insert the attribute GEH value, is below 5. If the answer is yes, I want to get answer yes. If not, I want to get answer no. And if the link or connector doesn't have any counted data, I want to keep the attribute empty. Here as a data type, I need to switch to text because I used strings here. Okay. Now I can add this attribute to the linked list, GEH check, and I can run the simulation. I will switch to quick mode to get the results as quickly as possible. Here in the status bar, you can see that I have 2 simulation runs. The first one was completed. I have to wait a couple of seconds to complete the second one. Now it's finished. Now here in the linked list, you see the calculated values for GEH statistic for each connector in this node, and also you see the answer if the condition is fulfilled or not. Now let's say that I want to visualize these results. For that, I can go to the links and I can change the drawing mode from use constant colors to use color scheme. And as an attribute here for classification, I can use the GAH value. Then I need to set boundaries here. So values under 5 will be colored by green color. Values between 5 and 10 will be colored by yellow, and links or connectors with GH value above 10 will be colored red. Okay, and then you see a graphical representation of these results. Now I am going back to the presentation. Example number 3, node level of service calculation. I will calculate the level of service based on highway capacity manual table where the threshold values are given for control delay. Please take note that the control delay used in HCM is not exactly the same as vehicle delay in the microscopic simulation. So please take into account all differences between HCM procedures and the microscopic simulation when interpreting the results. I will read additionally and explain 4 user-defined attributes for the node. LOS for calculation of the average node LOS, worst LOS for calculation of the worst node LOS, worst move LOS for calculation of the worst movement LOS, and the last one is LOS label to show the results in one label. Now let's go to Vissim. Again, a very simple network. I will open the list for user-defined attributes. You can see here that there aren't any user-defined attributes yet. And I mentioned that I don't want to create them here, but I want to read them additionally. So I go to File, Read Additionally Network. I will choose the Vissim file where my user-defined attributes are stored. Then I will click on Select None, and I will click here, Read User-Defined Attributes. I don't want to read the other things. Okay, now I have 4 user-defined attributes in my Vissim file. The first one is used to calculate level of service for the node. For that, I used 5 functions. If, here you can see that this is a question. If the vehicle delayed from total results is below 10, then the answer is A. If not, then it goes to the next question. If the vehicle delay from total results is below 20, then the answer is level B, and so on. These threshold values here are according to the HCM table for signalized intersection. The next one, here I use the same principle. Here are 5 conditions, and I'm asking here if the vehicle delay from total results, the maximum through all simulation runs and all time intervals is below 10, then it's LOS A, and so on. The difference here is that here I choose the maximum. This first line here is as a question if is the attribute empty, if not continue with LOS estimation. The next one, again the same principle, 5 conditions, 5 times the functions if, but here I'm asking if the vehicle delay for movements, the maximum through all simulation runs and all time intervals is below the threshold value. If yes, then the attribute gets this value A. If not, it goes to the second condition. So the same principle. And the last one here, this is will be used as a label, and there is a combination of text in quotation marks and the value of attribute. This is attribute I created, and also the others here. I want to show the current LOS, the LOS for the last interval, time interval, the worst node LOS, and worst movement LOS. This user-defined attributes is defined for nodes, so I can switch the label for nodes on, and as a label attribute, I can choose here my attribute node label. Then I get this label here. Now I can run the simulation. And here you see the value of the current node LOS. This value is calculated during the time. For the value for the last interval node LOS, we have to wait a couple of minutes until the first time interval is completed. The time intervals are set to 5 minutes in this example, so we have to wait 5 minutes to get this value. The values for worst no LOS and worst movement LOS we'll get after the first simulation run. Here in the status bar, you can see the simulation time. We have to wait until 5 minutes to see the second value here. And here you see that I'm using 2 simulation runs in this example. Now the first time interval was completed, so we see the value for the last time interval, node LOS. And now I will switch to quick mode to get the results. Now the simulation is completed and I see all the values for all attributes I defined. I also can to show these results in a node list, where I can add to the list the values for each time interval and each simulation run, and also the worst values for node and movement. And then you can see the results in the list, the same results as in the label. And again, to get the results, the evaluation must be switched on. In this example, evaluation for nodes. That was example number 3. I will switch back to the presentation. Coming to the end of this webinar, let me summarize shortly what you can do with user-defined attributes. User-defined attributes are part of the basic PTV Vissim 8 version. That means you don't need any additional module. Training examples will be available soon. With the new Vissim release, also some additional possibilities will come. For example, user-defined attributes for child objects like movements. Values for your defined user-defined attributes can be obtained via the COM interface or DLL interfaces. What you can do with user-defined attributes: for network objects, you may define further attributes in addition to the input and output attributes. User-defined attributes may be edited and managed in lists in the same way as predefined attributes. The data source type of a user-defined attributes may be based on data or formulas. You may read in user-defined attributes additively from another Vissim network. Before we close, I would like to point you to our webinar archive, where you can find the video with this and all other webinars. You also can find numerous Vissim application videos on our YouTube channel, easily by searching for PTV Vision in YouTube search, or simply by opening the PTV Vision channel, www.youtube.com/PTVVision. That led us to the end of this webinar. Thank you for your interest in microsimulation and for joining our webinar. Should you have any more questions, you can still ask them using the questions window. Sven and I will stay online for a few more minutes and write back to you. For all those leaving right now, all the best to you and have fun modeling with PTV Vissim.